Now let's do one that we can't do in our head, that we have to actually write under each other and multiply. I want to multiply 2 4/10 by 3 25/100. Now, it doesn't really matter which one I put on top when I get ready to multiply, because multiplication, as you remember, is commutative. You can change the order of the way we multiply. So since the 3 25/100 has the most digits, I'm going to put it on top. So I'm going to write down 3.25. And then when I get ready to write down the 2 4/10, I imagine that there's no decimal there, and just write it down like 24. In other words, I really write the problem down like it's 325 multiplied by 24. Then I go back and put the decimals where they go. So I line it up just like the decimals were not even there. And then I multiply like the decimals were not there. 4 times 5 is 20. Carry your 2. 8 and 2 is 10. Carry your 1. 12 and 1 is 13. Then I'm ready to multiply by the 2. 2 times 5 is 10. Carry our 1. 2 times 2 is 4 and 1 is 5. And 2 times 3 is 6. Have to ignore my first carrying up there. Then when I add this up, 0, 0, 8, 7. Now I look to see how many decimal places I have in my answer. This one has 2 decimal places, that factor. This factor has 1 decimal place. So my answer should have 3 decimal places. You count the number of decimal places, find the sum of the decimal places and the factors. Your answer should have that many. So I need to have 3 decimal places. So I count 1, 2, 3. So my answer would be 7 800 thousandths. Now, if you did that problem on a calculator, you would not see the same answer. What you would see on the calculator would be 7.8 for the answer. As you remember, you can always add zeros on the end of a decimal number without changing the value. So 7.8 is equivalent to 7.800. We can just drop those 2 zeros off. And since we can do that, we usually don't write them. So the answer is 7 8/10. Now you have to put, you count the zeros in getting your decimal place, but once you get your decimal place, you can drop zeros off on the end. So what I'm saying is, you could leave the zeros there and say your answer was 7 800 thousandths, or you could drop the zeros off and say your answer is 7 8/10. They mean the same thing, so either answer is correct. Now, if you had written this problem down just as it was, and written down 24, 325, now I need to go back and put my decimal points in. You line them up like it was 24 and 325. If you'd multiplied it this way, you'll get the very same answer, because we can multiply in any order we like. I just chose this way because there were more digits in the 325. Let's do another one. This is 4 16 thousandths multiplied by 305 thousandths. Now, if you notice, when I wrote this one down, I wrote them down first like there were no decimal points there. So I put 4016 and the 305 and lined them up like there were no decimal points there. Actually, it ends up the way this particular one works out, but the decimal points do end up being under each other. But you actually write it down like the decimals weren't even there. Now, I didn't write the 0 down with the 305 thousandths. It's just easier for me not to have any extra zeros around. It's fine if you put that 0 down. Okay, let's multiply this out and see what we get. 5 times 6 is 30. Carry our 3. 5 and 3 is 8. 5 times 0 is 0. 4 times 5 is 20. Then if we multiply by 0, we can just put 1 0 down to hold the place and go to the next number, or we can put the zeros all the way across, whichever you prefer. I'm going to just put the 1 0 down to hold the place and go ahead and multiply by 3. 3 times 6 is 18. Carry my 1. 3 times 1 is 3, and 1 is 4. 3 times 0 is 0. 3 times 4 is 12. I total that up. 0, 8, 8, 4, 2, 2, 1. Again, I count my decimal places. This one has 3. This one has 3. So my answer should have 6. 1, 2, 3, 4, 5, 6. So that looks like it's going to be a really large number, but it's actually a small number. It's just 1 and a fraction. Now, we could, if we'd like, leave off the last 0 and let this be our answer. And if we wanted to read that answer, this is tenths, hundredths, thousandths, 10,000ths, 100,000ths. So we'd have 1 and 22,488 100,000ths. But our whole number is only 1. Now leaving off that 0 is your choice. You can leave it exactly the way you get it, or you can drop the 0 off when you write your final answer. We often end up multiplying decimal numbers by powers of 10. So I thought we'd look at this and see what happens. If we wanted to multiply 9.18 by 10, actually going to write it this way so I could just bring the 0 down. Then 8, 1, 9. If I count my decimal places, I had, move this down a little bit. I had 2 in this one, none in this one. So my answer should have 2. So if I count 1, 2, I would get 91 and 80 hundredths. Or I'd probably just write it 91.8. So let's put up here our answer is 91.8. Now let's look at another one. Let's do 3.2 times 100. But do that one. 3.2 times 100. This time I'll go ahead and write it this way. But I'm just going to put the zeros down to hold the places and then say 1 times 2 is 2. 1 times 3 is 3, and I only have 1 decimal place, so I'll put in my 1 decimal place, and we probably write that answer 320. So we'll say our answer is 320. Let's look at one more example before we try to see sort of a pattern. Let's multiply 8 hundredths by 10,000. I'm going to go ahead, not going to write that 0 down, but I'm going to write the 10,000 under here because I can just hold the places with the zeros. I'm going to hold this place, and this place, and this place, and this place. 1 times 8 is 8. 1 times 0 is 0. And I have 2 decimal places there, none here. So my answer should have 2. Now I've got what that number actually is just 800. Now, let's look at what we started with. We'll go all the way back to the beginning. Let's go back to the beginning and look at this one. We started off with 9.18. After we multiplied by 10, we ended up with 91.8. Actually, you see we have the very same digits that we started with, but our decimal is just in a different place. It's actually 1 place farther over. Here, when we multiply by 100, we still got the 3 and the 2 again, but our decimal's in a different place. Notice that it was 3.2, now it's 320. It's been moved over 2 places. When we multiply by 100, it got moved over 2 places. When we multiplied by 10, the decimal got moved over 1 place. When we multiply by 10,000, notice we started off with 0.08 and we ended up with 800. The decimal got moved over 4 places.